For our next project in automation and robotics, we are going to again go to the table of contents, and you're going to do the next thing within the system. This is going to be the Mechanisms Toolbox. You can find this under Lesson 2, Mechanical Systems, subsection Mechanical Gears. What you're going to do in this section is go through and you're going to create the gears listed in this section. You can see here that we take a base plate along with a large long flat plate, a 5x25 plate, a 5x25 C-channel, 5 1-inch stand-ups, and 13 of the shorter screws, and 3 nuts. You will create this base plate. Throughout the entire process of this, you will not disassemble this main base plate at all, or this test plate at all. You're going to build your individual machines on here. You're going to sketch them. You're going to take note of what their directions of motion, input and output are, and what's going to happen when they're being used. And then you will disassemble it before going on to your next one. I will also be including a video of me building these in the materials with this. The first set you're going to build is a simple gear train. The simple gear train is 2 spline gears together, and one spins, causing the other to turn. The second is a simple gear train with idler. This has 3 spline gears, and the middle gear reverses the direction of the output gear. So this input gear will go in one direction, and this output gear will go in the same direction, whereas when you have a simple gear train without idler, the gears go in opposite directions. The size of the middle gear does not matter. Next up, we have a bevel gear assembly. Please look at the example provided in the classroom or at the example video that I have provided as to how best to make your own bevel gear, because this design is not ideal. The bevel gear itself changes the direction of motion by either 45 degrees, 90 degrees, or I believe 120 degrees, depending on which set of gears you use. The next up is the worm and wheel gear. Here you can see the worm part has the input power and the wheel is the output power. This also changes the direction of motion by 90 degrees. Next up, we have the lead screw. The lead screw is a reciprocating linear design. Here you have a track based on the bottom with these 90-degree corners and a green piece of guiding track that goes back and forth along this while following the screw design. You can follow the example that I have in the classroom or the example in the video that goes with this. Next up, we have the rack and pinion. This one is very difficult to build, even though it may look easy. Most importantly, be sure that you make this C-channel the first thing that you build before anything else. And remember that you can screw directly into these green slides. After that, you will have the universal joint. I strongly recommend that you do not use the universal joint design here because cutting metal may not be available. What you can do instead is use the smaller U-shaped channel and then put the 2 gussets, which are these things right here, on the sides, and then the black bushing will go at an angle between the 2, leaving you one hole open in the center to make the universal joint go out. The universal joint is used for changing the direction of power less than 90 degrees. I believe it goes to just over 45 degrees. The chain drive should look familiar to you. This is what most bicycles use, a chain input and output. The great thing about a chain drive is that it can be used at any angle, and unlike the other systems, does not need to have the 2 shafts in line with each other. Next up is the belt drive. In this class, we will not use the belt drive because the design created here is very difficult to use and does not work in the classroom. After that, you have the crank and slider. The crank and slider uses a cam to move the slider back and forth. You'd see this similar to something on an old train or on a Sawzall saw. And then finally, you have the cam and follower. The cam will go around in one direction, lifting this valve up and then dropping it back down. The cam and follower can only go in one direction. In my classroom, you should have available to you a 3D printed multi-directional cam. If it is not available, you can look up the print design on Thingiverse. You just look up Vex Cam and you will find it available to you.